My name's Vinny Napolitano, and I'm doing my project on the physics of a roller coaster. The first roller coaster was created in 1884 in Coney Island, Brooklyn, New York, by a man by the name of Lamarcus Thompson. It traveled 6 miles per hour and costed a nickel to ride. Before I teach you about the physics of a roller coaster, here's some vocabulary to further your understanding on the topic. Acceleration is an increase in the rate or speed of something. We see acceleration a lot in roller coasters, mostly at the start of the ride when the cart accelerates to get itself up the ramp or just to start the ride. Friction is the resistance that one surface or object encounters when moving over another. We will see friction between the wheels of the cart and the rails that make the actual roller coaster go. Inertia is a property of matter by which it continues in its existing state of rest or uniform motion in a straight line, unless that state is changed by an external force. Momentum is the quantity of motion of a moving body, measured as a product of its mass and velocity. Momentum is seen when the cart rolls down the hill and the speed and velocity begin to increase. The movement of a roller coaster is accomplished by the conversion of potential energy to kinetic energy. Potential energy is the energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, and other factors. In simpler terms, potential energy is energy that is stopped and waiting to be used. We can see potential energy begins to grow as you go up the hill. As you start to descend, the potential energy is converted to kinetic energy. Point 1 has the most potential energy, while point 2 has the most kinetic energy. It is converted from potential energy to kinetic energy as the roller coaster goes down the hill. Kinetic energy is energy that a body possesses by virtue of being in motion. In simpler terms, this would be any energy in motion. We see potential energy at the very beginning of the ride when it is ready to begin. We also see the potential energy at the top of the bumps when they stop and get ready to proceed down the ramp. At the first point, the kinetic energy is at zero because the car is still at a stop point and not in motion. There is a lot of potential energy because the coaster is stopped at the top of the hill. At the second point, the kinetic energy and potential energy are around the same because it is in the process of converting from potential to kinetic. The velocity begins to decrease as you move down the ramp. Velocity is the speed of something in a given direction. At the third point, it's at its maximum level of kinetic energy because it's in full motion. It's at zero for potential energy because it has fully converted to kinetic energy. At the last point, it is being converted back into potential energy, so the kinetic energy drops and the potential energy rises. If you want to see how much energy there is, you can use the equation for total energy. Isaac Newton's laws play a large role in the way roller coasters operate. Newton's first law states an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. In one word, this is inertia. The object that is acting upon the roller coaster is the brakes and the rails. Inertia is the tendency to do nothing or to remain unchanged. Newton's second law states the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. The main equation for Newton's second law is the force equation, which is force equals mass times acceleration. Work is done in a roller coaster. Work is done when a force that is applied to an object moves that object. That equation for work equals force times displacement cosine of theta. The equation for work and energy relationship is kinetic energy initial plus potential energy initial plus work external equals kinetic energy final plus potential energy final. A question you may ask yourself is, how do roller coasters manage to stay attached to the tracks when going over a loop? It is a mix of a few things actually: velocity, gravity, and centripetal force. Centripetal force is the force on an object on a circular path that keeps the object moving on the path. It is always directed towards the center, and its magnitude is constant, based on the mass of the object, its tangential velocity, and the distance of the object radius from the center of the circular path. We see the demonstration of centripetal force when a car goes around the loop on the track and it stays.